This is the fifth session of AWS DevOps training, and in our last session we tried to understand the concept of Terraform, the syntax of the Terraform. We tried to understand the concept of by using this simple Terraform for provider. We use AWS, we use Azure RM provider, and we saw how its binary is pulled down automatically, the latest variant. Then we understand the concept of resource, we understand the concept of data, the output, and how we can create a variable, how we can use this length to get the value of the number of total, if we have a specific number of resources, so we can use the length function to count it. And then we simply create a VPC, and then we attach a subnet with this VPC. And we also understand these all concepts in detail. So today we have to understand, we have to deploy the complete VPC resources, whatever we learn from day one. So all these resources we will deploy with the AWS Terraform. So for this reason, what I create this whole Terraform. Let me just do a zoom in. So this is my provider. This is US West 1. Inside this US West 1, how many availability zones are available? I don't know. I mean, it could be, but you should be familiar with the command line. You should be equipped with the command line tools to get any information. So just like how many availability zones are in this zone, in this region. So what you can do, you can simply use the AWS CLI. So what availability zone so far I set in my AWS config. First I will see this. So this is US West 1, and here in my Terraform this is US West 1. So let me just switch my AWS CLI zone, and now by the command line I will run a command that will help me to fetch all the availability zones. So this command I can use. So AWS EC2 describe availability zone output table. If you are not setting output in tabular format, it will show you the output in the JSON format. So it's good to use output in the tabular format. It will be in the presentable format. So here you can see there are two availability zones. The names are US West 1A and US West 1B. So we fetch this information by the AWS CLI. So you can also get this information by Terraform, but you don't need to sometimes spend time on the Terraform, because AWS CLI sometimes is giving you a very quick information. Instead of writing Terraform and then running it, it is taking some too much time to process. So now we know we have two availability zone. Okay, good. Now we will create this VPC, and we use the same syntax. In this subnet we will create and enable DNS port true. I think this is by default is true, and enable DNS host name in whatever EC2 instance we will create. It will create a DNS entry for the public IP and this tag. In fact, these three are not mandatory. I explained you in detail in previous session. So, but I just refine this one. Then fetch availability zones. We did this last time in the data, and we just show all the availability zone. We don't need to do this, but This was the previous work. I just preserve it here just for your reference. Then what I did, I create the internet gateway, and simply I explain you AWS underscore internet. I just type int and it automatically lists down all the internet gateway related details. And I give the internet gateway name IGI in IAC. IAC stands for infrastructure as code. I just put everything with IAC just to have an explanation that this resource is created by infrastructure as code. Then in which VPC I want to create, I simply fetch the ID of the VPC. If you don't know this, this is just like a variable I explained you, but if you don't know, you can straightforward put the ID, but that's not a good idea. It's become dynamic. Whatever availability zone, whatever region you are using in which the VPC will create, its ID will automatically be fetched on the runtime. And then this tag I just associated. And then public route I created, and I set in this public route the default gateway. All the unknown traffic will go to this internet gateway. Okay, this is just a route as I showed you in the web console. Then the public subnet is created, and the same stuff we discuss in detail. Here we get all the availability zone count. Here we get the with which VPC we want to associate this public subnet. Here we define the Cedar subnet function, and this function is getting the complete Cedar pool, the bigger pool, whatever we gave with this variable. And then I explained you that this is the 4-bit it will take from the whole subnet to borrow to create the subnets. And then count star 2. So count first value is 0, and then first time it will be multiplied by 2 will be the 0. It means the 0 subnet. And then the very first subnet is known as 0 subnet. And in previous session I opened the subnet calculator and I did the subnetting with this subnet, whatever subnet we used, and we calculated the total subnet. For example, we get the 8 subnets. So first subnet is 0 and last is 7. So first subnet 0, and then next time its value will be 1. So 1 multiplied by 2, then 2. It's mean the 2 subnet mean the third subnet. 0, 1, 2, the third subnet. And again, if there are 3 availability zone, then third time its value will be 3. Third time its value will be 2. 2 into 2, 4. So 0, 2, and then 4. These subnets will be associated with the public subnets. So that's why I attach here 2. Even if you can remove this, but in that case you will just get the very first 3 or 2 whatever subnets are available. And in the private subnet I did this, I multiply by 2 and then plus 1. So this value is creating even values, and this is creating odd values. So first time 0 plus 1, 1, second time 2 plus 1, 3, and then 2 into 2, 4 plus 1, 5. So 1, 3, and 5. 1, 3, 5 subnet will be associated with the private for the private purpose, and 0, 2, 4 will be associated with our public subnet. So with this way we allocate our subnets. So this was just a tricky part, that's why I spent some time to explain you. And here I set the public subnet IP to true. You can also set this to false, because later on we can also attach the with the EC2 instance with the public IP, elastic IP. But if you set this true, it will automatically attach the public IP with the public EC2 instances. So definitely if you are launching some EC2 instance in the public subnet, you would like to have some public IP. If you don't want to have the public IP, you will definitely go to the private subnet. So in this case it's false. And I also showed you that we can attach the public IP with the private subnet EC2 instance, but it will not work. Okay, so I hope this is clear. This public subnet, private subnet, and in which VPC it will create from this VpcID it is fetched. AWS vpc.vpci by isc.id. Simple. So this I used, and you could have the multiple VPCs, so that's why it will only fetch the relevant VPC IP. ID. Then private route table. So public route table we also already created and attached the internet gateway, and this is our private route table. And in this private route table, I just created the route table in this with this name in this VPC, and we just attached the private subnet with the AWS route table association. I showed you in the AWS console in the previous session that there are the list of associated subnets that will have this routing table. So how many subnets we have, it will count, and then it will attach the subnet, all the relevant subnet step by step with each with this routing table. And with which routing table? This routing table what I created here. So this value dot this value dot id. Okay, so it will associate all the private subnet with this routing table, and then this will associate all the public subnet with its public routing table. The next, I am going to generate some elastic IPs. So I just use the AWS EIP resource, and then this is a name I gave the NAT EIP. So I am going to create 4 NAT gateways for each availability zone for the public, for the private, and the length will be count in how many availability zone we have. The same function we will use. It will give us the exact figure of how many availability zone we have. And domain is VPC. Under the VPC domain it will create, and then I just attach the tag. So it will create 4 elastic IPs, and the tag of each elastic IP will be NAT IP -0, 1, 2, 3, something like this. And then NAT gateways. So AWS NAT gateway resource. This is the name. How many availability zone we have, count, allocation ID. This is basically the elastic IP, whatever IP we have associated .id. So every IP also has its own ID. So IPs, all the resources in AWS are represented by the ID. So that's why we are using ID. And which subnet we want to associate with this NAT gateway. Okay, it will define the subnet, and this is the tag. So each NAT gateway will be created just like NAT gateway 1, 0, 1, 2, 3. So these are the elastic IPs, these are the NAT gateways. Then what I did, I create a key pair in AWS. So when you are working with the console, so console is giving you a leverage to create the key pairs. So the key pairs are by default generated by AWS with 2 formats, .ppk, .pem. PPK is usable for the Windows-based SSH clients, and PEM is for Linux to make the SSH. But here what I did, I used this AWS key pair resource. This is the name of the key pair, and key name, this is the key name. Then Here I define the public key that will be automatically published to the EC2 instance, whatever EC2 instance will be created. So where is this public key? In fact, what I did, in Linux, we are using a command ssh-key gen. So this is a very well-known command. This command will generate a key pair in our user home directory, and we can use this key pair to associate. We can use this key pair to provide to make the public and private keys to make the communication passwordless access to our EC2 instance. So here the in the user home directory .ssh you can see this ID is generated. Okay, this is just generated. So this is the public key, this is a private key, this is the public key, this is a private key. I just created this. So already this was available, but when I again ran this command, it generates this new one. So this public key path, this complete path, we have to publish, we provide in our Terraform. So this is the path where our public key is available. So same command you can use if you are running Terraform in Linux, you can use, and you can give the path of the your public key. But here I use double backslash just to avoid some syntax error of Terraform, because single backslash will make the problem. So you must have to type double backslash wherever you have to complete the path. So this public key will be used, and the private key we already have. And then here we have to create the security group. So here we created the AWS security group with the name WebSG, and this is the name. This is with which VPC it will be residing in. So this is the VpcId, what ports I want to assign. Okay, what outgoing ports I want to assign. So 0 mean all the ports. Okay, and this mean all the IPs. So 22 port I allowed only for SSH, and I create this web instance SG, and then I create an EC2 instance by using AWS instance resource, the AMI, the elastic machine image. So this AMI I use for Ubuntu. So you can fetch the AMIs by AWS CLI, or you can directly go to EC2. I don't remember right now what is the exact command to list the AWS AMIs, and there if you will run in AWS CLI, it will take a lot of time. It will give you uh, a huge big list, so it's very difficult to get all the relevant value by the AWS CLI. So you can directly go to AMI catalog. Obviously you can apply some filter in AWS CLI to get your relevant value, but it will first compile all the results, and then it will apply the filter on your selective image name. So it will take some time. So that's why I'm not using AWS CLI. So Ubuntu, for example, I want to use Ubuntu, and you can see this is the ID of the Ubuntu. Okay, so whatever image you want to use, I mean, this is the older version, this is the latest version. Whatever image you will select here, it will give you the ID. Okay, you can select the different variant. So this is the ID I want to use for my EC2 instance. So I believe I put the same ID. Yes, this is the ID. And I want to use the instance type T2 micro, the key name, this key, whatever I created here, AWS key pair dot IAC key pair dot ID dot key name. So when you will put here a dot, it will automatically list you down either the ID or key. Okay, so key name it need, not the ID, and the subnet ID, which subnet will be attached with this EC2 instance. So we list down by the command line. We have two availability zone, and first one is US West 1A, second US West 1B. So when I will use 0 ID, so it will be in the first available zone. West 2A, I think I just gave some wrong comments here. West 1B, yes, it's not 2, it's 1. And let me just confirm my, yes, first one. So here I just gave this 1A, this 0 mean the first subnet, the first availability zone subnet, and associate public IP address true mean the public IP will automatically be attached with this instance. And security group we already created, we provide the security group ID, and then the tag, this is not mandatory. Similarly, and then I use the output function. We understand this output function in detail, and here what I did, I just printed the value of AWS instance.web instance public IP. Okay, so this will show us in at the end of this completion of this Terraform that what public IP is associated. You don't need to go to your console. And again, I created a AWS security group for the second instance. I gave the name, I allow SSH access, and I allow ping traffic from everywhere to just make sure that this instance is reachable, outgoing traffic all, everything allowed. And then AWS instance we created, we gave the ID, let me just put the right ID, and T2 micro, the key pair. In the first private subnet, I created this DB instance. The first one was a web, and this is just like a database instance. And it is not publicly exposed. The web instance is publicly exposed. VPC security group, I just created a specific security group. This one is attached with this database, and then I just printed here the AWS instance DB instance private IP. So it will just show us the private IP, and then we can do SSH to the public IP of the web server, and then we will jump into this database server. So all these resources will be created. So let me just save it once and open the terminal, and we will do Terraform. I will do first plan. It will take a while. Okay, the plan ran successfully, and here the complete output is there. Let me just reduce the font size, and here you can see a complete list of all resources is given, whatever it will be creating, and we don't have any issue. So for plan will give you the output, either the syntax is good and it is a dry run where whatever it will create, what subnet will be associated, everything is given in the plan. So we are good with this plan. We can simply now apply. It is asking to type here yes. Okay. So it is creating the resources now. Okay, this is done, but I got an error while it is going to create the EC2 instance. It gave me error. This ID does not exist. So I think I used some wrong ID, AMI05D38. The ID is good. What happened here? Okay, the EC2 instance is created. The issue I fixed, and the issue was I was using the wrong ID. In fact, the AMI's ID for each region are different. So we are working in US West 1, and from here I was using US West 2, and in US West 2 this is the ID of Ubuntu Server 24.04 LTS. But if I go to US West 1, these IDs are entirely different. So I selected the wrong region, that's why it was not working. Now I ran again Ubuntu. You can see this is the ID of this is a different ID. So I use this ID now, proper region here, and now it's working fine. So this is the ID. So now the EC2 instance is created. And let me just maximize this output. You can see here everything is done. All the resources are created. The DB instance is created and web instance is created. Web instance I created in the public subnet, DB instance in the private subnet. Very simple. And here is the output. We have these two availability zones, and this is the public IP of our instance created, and this is the private IP of our database created. So let me just quickly copy this IP and try to do SSH to my database created. If I quickly go to my proper region, here West 1, instances, so these instances are created. So now I will just go to my mobile exterm, and here I have to open a new session. Public IP username, I know it's Ubuntu, and in the advanced setting use private key. So the key I created in my Windows by using ssh-keygen, this private key I will use to, because I published this public key, so that's why I use this private key. If I use this public key, then I will use this private key. So then I just need to select this, open, and perfect. It is connected, so it's mean everything is done perfectly. We are landed in our web server. This IP is this. So what is the private IP of our database? So here we can see 100, 100, 121. I do a ping. Yes, working. So, I also added the ICMP. By default, ICMP is not added in the security group. So I allowed ping and SSH. So, to do the SSH, I need the private key. So private key I don't have here. So what I can do, I will simply upload the private key, this private key, by taking the leverage of this MOBAX term in my web server. It's uploaded, and chmod 0400 should be the permissions, otherwise it will not allow us to do SSH. So this is our IP. I want to do an SSH to by using -i id public id RSA, and then ubuntu @100 Okay, great. So you see the ID we generated, we don't need to take care of the PAM or PPK. The AWS is providing us the different format. But if you generated your own key, so Terraform help you to use your generated key. You don't need to take this key pair generation service from the AWS. Although this is free, but it's very easy to generate and publish by Terraform. So now I am in the database server, and if I do a ping to internet, it's not working. What is the reason? The reason behind can be, if I go to the VPC, I hope I am in the correct region. Yes, I am. US West 1 VPCs. So this VPC we created, these all subnets are created. Route table. In the route table, this is our public route table where we associate both our public subnets. And here in the route, we give the default route. That's why we can reach to the public subnet by using the public IPs. Here in this route, we have not added, we created the NAT gateways. We have 2 NAT gateways, but the thing that we have not done, that in the private route table we have not added the route that will make the internet connectivity to the private subnet. this we have not done by the Terraform. So this is your assignment. You have to do this activity by Terraform. I did this with Web Console, but this is not a difficult job. Just create a with the same way you can add inside the route the NAT gateway. Just like I add the internet gateway in the public subnet. Now let me just go back to one ping internet. Now it's working. So thing is not been done by Terraform, so you have to add this functionality in the Terraform. That NAT gateway should automatically be added there. So I hope you got the idea how we did this with our Terraform, everything, and everything is working fine. So in the next session, we will see S3 service, simple storage service of AWS, and some security related concepts of S3, and then we will implement first with the web console, and then we will implement the Terraform to run the S3 service. So I hope you are good now. You got the concept. If you have any confusion, you can leave in the comments. Thank you.